Today we will be looking at two problems which is from a math contest in Malaysia, and that is the country where I live in, and that is from the math contest known as the Chen Jingrun's Cup Math Competition, and it's from the year 2021. So the first problem is to find the largest integer less than 1000 which has exactly 7 positive factors. And then for the second problem, we are given that a sub 0 is equal to 1 and a of 1 is equal to 1 over 2, and for all n bigger than or equal to 1, the sequence an satisfies the following recursion, which is a sub n plus 1 is equal to a sub n minus 1 over 1 plus n times by a sub n minus 1 times by a of n. And then what we will find is that the value of 1 over a of 99 times by a of 100. So before we look into the solutions to these two problems, I want to mention that this competition in Malaysia is actually to commemorate one of the great Chinese mathematician, and that is the Chen Jingrun. And he himself had made important contributions to the field of number theory, especially in the theory of prime numbers. Especially he had proved the 1 plus 2 version of the Goldbach Conjecture in the year 1973. And this theorem is also known as the Chen's theorem. So briefly talking is that the n plus 2 version of the Goldbach Conjecture is the fact that given any sufficiently large even numbers, you can express it either in the form of the sum of two primes or a prime plus a semi-prime. And by semi-prime I mean that it is the product of two primes. So it is very close to proving the real Goldbach conjecture, and that is every positive even numbers can be expressed as the sum of two prime numbers. So let's get into the two problems over here. So for the first problem, essentially we recall that if we are given an integer which we have n over here, and we can express it as the product of primes, which is, let's say, is p1 to the power of i1, p2 to the power of i2, p3 to the power of i3, so on and so forth, up until p sub k to the power of I sub k. We know that the number of positive factors in this case of the integer n is well known to be equal to I sub 1 plus 1 times by I sub 2 plus 1 all the way to I sub k plus 1. So therefore, in this context over here, we see that if we have that n is less than 1000, and then the number of positive factors of n is equal to 7, we must have that n is equal to p to the power of 6, where p is a prime number, because we equate this expression over here to be equal to 7, and because 7 is a prime, we must have that n to be equal to p to the power of 6. And so essentially we just want to find p such that p to the power of 6 is less than 1000. And for this, we also have to find p is the largest. So we can try some values, and what you note is that 3 to the power of 6 is equal to 729, and that is less than 1000. And then obviously you can check that 5 to the 6 is greater than 1000. So therefore, our answer to the first problem is just 729. And now let's move to the second problem. So for the second problem, we are given the fact that a of n plus 1 is equal to a of n minus 1 over 1 plus n times by a of n minus 1 times by a of n. And then based off the fact that we want to find 1 over a sub 99 times by a sub 100, we can actually try to come up with some expressions that are the reciprocal of the a terms. So in this case, we can try to take the reciprocal both sides, which will get that this is 1 over a of n plus 1 is equal to 1 plus n times by a sub n minus 1 and a sub n over a sub n minus 1. And then now we can split this fraction into two parts, which is 1 over a of n minus 1 plus n times by a of n. And then notice that the thing that we want to find contains two terms in the denominator. So this motivates us to just divide the both sides by a of n. And so this will give us 1 over a sub n, a of n plus 1, is equal to 1 over a sub n minus 1 a of n plus n. And then we can note that this term over here is essentially n being replaced with n minus 1. So in other words, we are descending by 1. So this means that we can take 1 over a of 99, a of 100, and we can descend it by 1, which is 1 over a of 98, a of 99, plus 99 in this case. And then let's descend it one more time. We get this a of 97, a of 98, plus 98, plus 99. And then effectively, we can just descend it all the way to 1 over a sub 0 times a of 1 plus 1 plus 2 all the way to 98 plus 99. So we just have to compute this whole thing over here, which I'll do it right over here. So this means that 1 over a of 99 times by a of 100 is equal to 1 over a of 0 and a of 1 is just equal to 2, which is given from the initial conditions. And then 1 plus 2 up until to 99 is just 99 times by 100 over 2. And then you can quickly compute this out, which in the end you get this is equal to 4952. And so this is our final answer. So if you want to solve more math problems from Malaysia, then be sure to check out this video over here.